Continuing with the numericals on power net calculations. In the last video we have seen the numerical, that is the bottom part of the that particular problem is not visible properly. Just I will show you that first, then we'll move to the next numerical. Okay, and that is what I mean is this we are specifying the all the component for the previous video numerical. We're all explained here how to transfer the base quantity in the different parts of the circuit. Okay, you have calculated all the system per new per values. Then that is not visible at that time, that is 0.2240, and also for transmission transformer T3 it is 0.086. Similarly for transmission line the value is 380.88 ohm, that is 0.0656 is the new per unit value of Z25 ohm transmission line. Then for drawing I told you that is you have to draw all the three buses, bus number 1, 2 and 3. Then we have a ground line here, you can look into carefully here. See here, bus number 1, 2 and 3, then here it is a ground line. Then I told you G1, G2 and G3 they are starting from the ground point. Therefore I am drawn from the ground to G1 and its reactance to the bus number 1. Similarly from ground to, because all the extreme ends of the power system components they are starting from the ground, therefore it started here and there is a reactance, it is connected to the bus number 2. Here also for bus number 3 there is generator G3 is connected, here G3 is connected. Then you are shown there, that is from transformer T1, then transmission line Z50, then T2, that is this T2. Then the another the line which is starting from bus number 1 is it is through T1 and J25 ohm reactance, then the T3 and it is connected to the bus number 3. Then bus number 3 there is a T3 and J25, that it is a T3 and J25 ohm which is connected to bus number 1. This is how we have to draw the reactance diagram for the last problem what we are seen in the last video, which is not visible the bottom part. That is why I just repeated this particular the reactance diagram. Then we'll move to the next problem. That is the statement is draw the impedance diagram for the given power system, and he is given the base quantity here 50 MVA 20 kilovolts in the 100 ohm line. Can see very carefully here. That is given the base quantity as 50 MVA 20 kilovolts in this particular circuit. Then from that you can calculate the base quantity in the other parts of the circuit. That will go ahead with that the calculation now. Okay. Then all the rating of the generator G1, G2 and Z3 and transformer T1, T2 and T3 is given here, that is T1. And one more thing, extra thing you can observe here, for the transformer T2 what is given is transformer T2 is a single phase unit, each having 10 MVA, one side is 123 kilovolts, the other side is 18 kilovolts. Then it is given means this T2 is comprises of 3 transformer which is connected for a particular fashion, either star delta, delta star, or whatever depending upon the voltage line on a voltage level of 100 ohm and generator side C2. That is the single unit of a 3 transformer they are connecting for this T2 operation in 3-phase mode. 3-phase mode. How to convert that rating? I'll take a first. Then we have to specify the rating of each component on the system. Okay. Now I am taking the same network once again, and I'll specify all the rating of the machines here. 20 MVA here transformer is once again looking into the voltage level here 138, sorry 13.8, because here the voltage level is 13.8. Okay, then if you look into here while choosing the T3, here it is a 22 kilovolts, here it is 20 kilovolts. Therefore appropriately you have to choose the voltage level on either side. Then the important thing is this transformer T2 is having the single phase in it. Then how to convert for the three phase? Just I will do that here. That is one side of the transformer, that is T2. The T2 rating what is given is, that is, it is a 10 MVA, 10 MVA, 10 MVA. One side is 127, then the another side is 18 kilovolts, 18 kilovolts. Then roughly you can look into here, it is 13.8, and the base quantity what he is chosen here in the 100 ohm resistor is 220 kilovolts. Okay, we'll see that one. But you look into here, the voltage level on the transmission line side is, it is around 220 kilovolts or odd. Therefore what you have to do is, it is single phase unit. If you are connecting in the star side, in the this side, this is a phase value, this is a phase value. Then how to calculate for if the all the three transformer are connected in star mode in the transmission line side, the line value what we are getting here is root 3 times 127, root 3 into 127. We are getting around that is 220 kilovolts, 220 kilovolts. So that this 220 kilovolts can be matched with the high voltage transmission line. Therefore the single phase unit you have to convert into, that is star side in the transmission line side, so that 220 and 220 is matching. Then look into the generator side. You look into generator side, it is a G2. The G2 voltage rating is 20 kilovolts. It is a 20 kilovolts. Then what is the secondary of the single phase transformer? It is 18. Suppose this side if you are connecting in delta, phase value, phase voltage is equal to line voltage. Phase voltage is equal to line voltage. Therefore that is, it is 18 kilovolts. You connect in delta so that you are getting 18 and it is matching with the rating of the generator. This is how you have to choose the rating of the transformer T2. Accordingly you have to write for three phase, and at the same time the rating of the individual transformer is 10 MVA. Therefore three phase, ultimately this generator, this transformer T2, it is 3 single phase transformer. Total capacity it will be 30 MVA, 30 MVA, because 10 into 3, and primary side it is 127 into root 3, which is connected in star, and the secondary side it is connected in delta, so that you are getting 220 divided by 18 kilovolts, 18 kilovolts. This is how you have to get the rating of the, that is the transformer T2 for three phase connection. Okay, the same thing I written here. Okay, see here what I am getting is 30 MVA, 220 kilovolts, 18. How I am getting? The rating of the individual transformer has got 10, therefore 3 into 10, 30 MVA, and this side is connected in star, therefore it is 127 into root 3. You have to choose the side here, so that which side it is connected, which side the generator is connected. What is the rating of the voltage rating of the generator? So that what I am connecting is 127 into root 3, that is in star, that is 220 kilovolts you are getting. And the second side I am connecting the delta, therefore phase voltage is equal to the line voltage. Then he asks you to take the base voltage as 220 kilovolts and base MVA as 50 MVA in the J100 ohm. Then this base quantity you have to transfer to the other sides. It is a very simple. Now the base quantity in this circuit is remains same because as such there is no transformer in between. Then when if you are transferring the voltage, base voltage of 220 220, it has to through this transformer. What is the rating here? It is 13.8 divided by 220, and the base quantity of here it is 220. Then the voltage, what base voltage you are getting is 13.8. The same thing I am written here, that is 13.8 divided by 220 multiplied by 220, that is 13.8 is the base quantity what I am getting in the generator circuit 1. That is, you have to take the transformer ratio of this, because we are moving from this side to this, therefore you have to take 13.8 divided by 220 multiplied by 220, so that I am getting 13.8. okay. Now for the same base quantity should be transferred to G3, the same base quantity can be transferred to C2 through these transformers. Now I am looking for base quantity here. Base MVA remains same, 30 MVA, and this 220 should be transferred to this transformer. Then secondary is 18, that is towards the generator is 18, and towards the transmission line side it is 220. Therefore the base quantity what I am written here, it is 18 is this and 220 is the other side here, multiplied by this 220. So that what I am getting is the 18 kilovolts is the base quantity in generator circuit. Similarly, the base in this circuit should be transferred to here. Then the base MVA is remains same. The voltage how we are transferring, it is 22 divided by 220 multiplied by this 220. The same thing I did here, that is 22 divided by 220 multiplied by 220. That is 22 is this side because transferring from the other side. 22 divided by 220 multiplied by, sorry, this 220 is this, sorry, just okay, this 220 as from here, because this is towards the generator side, this is towards the transmission line side, then this 220 should be this value, so that what I am getting is 222 22 kilovolts is the base quantity in generator 3. okay. Now the next step is to calculate the per unit quantity of each equipment in the system. Once we know the base quantity, once again I displayed all the actual values or the old quantity and new quantity in the different parts of the circuit. That is mentioned here. These are the base quantity in the different parts of the circuit. okay. Base quantity in generator, base quantity in J20, base quantity in 100 ohm, base quantity in C2, and these are the base quantity in C3. okay. Now once again the standard formula I am using, kVO by kV new whole square into MVAN by MVA volt into Z per unit volt. Therefore for generator 1 the old quantities are, these are the old quantities, these are the new quantity. Then what I am getting here is J.5. Then I am going for G2. For G2 these are the old quantity, these are the new quantity. Just have to substitute in this equation, what I am getting is 0.33. Similarly you go for G3, these are the new quantity, These are the old quantity. Just you have to substitute in this equation. We are getting 0.275. Then the transformer T1, T2 and T3. Then T1 I am considering referring to Z1. If you are referring to Z1 for the transformer T1, then the base quantity of 50 MVA and 13.8 you have to take. The old voltage what you have to take is 13.8 kilovolts is the old voltage, and the old MVA is 25. Once again you can look into here, I am written here clearly. Then substitute in the equation, once again the same equation, we are getting 0.2. Similarly to T2 I am taking referring to Z2. For Z2, then referring to Z2, the voltage level, old voltage is 18, old MV is 30, and new MV and KV are 50 MV and 18 kilovolts. The same thing, once again I am substituting in this equation, I am getting 0.1666. Then for a transformer T3 I am taking Z3 side, that is generator side. Therefore you have to take this base values. At the same time, old voltage you have to take it as 22 kV, which is towards the generator Z3. Therefore you are substituting, we are getting 0.1428. Then for transmission line J80 and J100 ohm, the base values are same. Therefore actual values are given. You have to find out the base impedance. Therefore base impedance what I am getting is 968. These are the base values, base MV and base KV. From that, using the standard equation, I am getting the base impedance here. Then if you are dividing the base impedance to the actual value, that is 80 by 968, I am getting 0.0826 for this per unit value of the J20, J80, and for 100 ohm line what I am getting is 0.1033. Then once if you are calculated, you have to draw the reactance diagram. Here I have got mentioned here 2 lines I mentioned here. Then there are 3 generators G1, G2 and G3. They are connected to they are the extreme points of the network. They are starting from the ground. The same basic principle you have to follow. Therefore you can see here, this is the ground line what I drawn first. This is the ground line. Then first G1 you can start, that is G1 it is connected with, it is represented by source and reactance, new reactance. Then point A here, it is a point A here. Then transformer T1 having point 2, this is a point B. Then transmission line of J80, that is 0.0826, which is connected to C. Then from the C we have got 2 different branches, one towards the generator G2 and the to G3. Then from here there is a transformer T2, that is T3, that is 0.1428, then which in turn that is connected to generator. Ultimately generator is connected to ground because it is an extreme point of the power system. It is one more extreme point of the power system. Therefore it is start from ground. Okay. Then another part starting from C as the transmission line, that is 0.1033. Then there is a T2 that is connected to F, that is E is this point, and it is connected to this bus. Then this bus is connected to generator G3. In turn, G3 is the end of one end of the power system. Then it has to start from the ground. Therefore it is start from the ground. Z2 and its reactance you can mention. This is how we have to draw the reactance diagram for the given network.